What if I told you from this single image, I could create a 3D world and we could look at it from any angle? Watch this. This isn't just a cool visual effect, it's solving one of the biggest bottlenecks in AI today. And in this video, I'm gonna dive into NVIDIA's latest Gen 3C, which is an AI prediction model that uses their Cosmos World Foundation and mixes in 3D understanding of the world from a spatial image or video, and then can generate unlimited number of new videos and scenes from that one input. And I'm not just gonna tell you about this technology, I'm actually gonna get my hands on the code and I'm gonna show you how to set it up. I'm gonna show you some results that I generated with using images and videos, and you can start to see how well this works and where the limitations lie. Okay, so let's start with the problem. These perception models, these different models that lets robots sense the world that we live and interact in, takes millions of data points, trillions of data points. And to feed these data models, we have to give it millions, trillions, unlimited numbers of images and videos, so it starts to understand what this world is around us. Now, companies like Tesla has done a great job by crowdsourcing all of the footage from their Tesla vehicles, and they have a huge step up, but there's certain things they can't do. We don't have Teslas driving off the road. We don't have Teslas driving with a kid run in front of it. There's all these situations that we can create synthetic data with, and that's what Gen 3C does. It creates synthetic data so we can feed these perception models more and more images. And if you can't crowdsource your millions of vehicles on the road, how are we supposed to get all these images? There's only so many photos in the world we can go capture. If we're Google or a large company like that, we can send out tens of thousands of people. We can crowdsource people to get images, but only to a point. So once we get those millions of images from crowdsourcing, or in your case, a small company, let's say you want to take tens of thousands of images your team went and captured and turn it into millions of images, millions of video sequences for your machine perception models. We need something like Gen 3C. So let's jump into the project page for Gen 3C, where I can actually break down how this plays as part of the solution to that data collection problem. So if we go to their website, we see it's called Gen 3C, 3D informed world consistent video generation with precise control. And they have this great video. I think it does a pretty good job at explaining what happens. They're basically taking an image, turn it into a 3D model like you see here, and then it's doing some magic to recreate that scene in 3D. So if I fast forward here, it says generate, there we go. You got this magic scene like you walk through it. But if I go to the start of this, it started with that single image. So coming down here, you can see they have all kinds of examples of how they're doing this, but where I really want to focus in on is this. This is essentially how it works. It is the method. So with Gen 3C, we can take a single input image, we can take two images, or we can even take a dynamic video like this guy of this looks like a hippopotamus swimming. And from there, we can generate infinite new viewpoints. And so how does it do that? The first thing it's going to do is it's going to turn it into this what's called spatial temporal 3D cache, which I'm going to show you what that looks like. So think of this, I have an image or a frame from a video, and I'm able to use AI to predict the depth of that image. And that tells me how far for each pixel the surface that it's looking at is from it. So if I took a picture of someone, you'll have this great depth map where the person in front of you is popping out and the background's far away, and we know this. Then we can project that into what's called a point cloud. So what it's doing here is it's taking this depth map and it's making a point cloud. And then we're gonna have a virtual camera, and we're gonna say we're gonna move around this point cloud, and you'll start to see gaps and occlusions, which you can see in this part where there's occlusions. And that's fine because we don't know really what it looks like when things are blocked. But the beauty is then we use a diffusion model. So in this, we're gonna use Cosmos, but I think they even did the research to use stable diffusion, but there's different ways that you can then fill in that model. So we're gonna basically walk through this workflow, and you're gonna see how I made at the start of this video, how I kind of made that whole entire sequence. It started out with just that image at the street, and then all of a sudden I'm moving around. So it's pretty amazing. And if you look at this, you get some appreciation on this project page of what it can do. So you have your original, and then it's moving around a little bit. You know, driving simulation, you can like look from different lanes. You can go up in the sky, which I think is kind of silly. Cars wouldn't really do that, but you can basically simulate whatever you want. So I'm going to jump out of the theory and let's jump more into the project so you can see kind of how it works and get a better idea of what's going on when we do this. Time out. Before we get hands-on with Gen 3C, I want to say it's really important to have a grasp of programming and AI models so you can incorporate this sort of technology into your own computer vision projects. And that's why I want to highlight today's sponsor, Brilliant. Brilliant helps you become a better thinker and problem solver with thousands of visual interactive lessons in math, science, programming, data analysis, and AI. And what I love about Brilliant is how they structure their learning. They don't just throw advanced concepts at you. They start by helping you master the fundamentals, then gradually build up to more complex, challenging problems. It's like having a personal tutor that knows exactly when you're ready for the next step. And since I travel frequently for work, I'm always worried that I'm going to lose some of this foundational knowledge. And that's why I appreciate the Brilliant app that makes it easy to learn anywhere with fun, hands-on lessons. Brilliant's growing collection of programming courses have been particularly valuable for me. It's actually expanded my skills so I can incorporate AI models like this one we're discussing in today's computer vision pipelines. These courses are a great way to build timeless problem-solving skills to thrive in the evolving world of programming. From learning Python to developing intuition for computer logic, you'll get hands-on experience with real programs to think like a real programmer. To learn for free on Brilliant, go to brilliant.org/pixelreconstruct, scan the QR code on the screen, or click on the link in the description. Brilliant also gives our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Thanks again to Brilliant for sponsoring this video. So now let's get hands-on with Gen 3C. Okay, so here's the GitHub repository, and here's where the magic happens. I'm not going to walk you through everything. If we want a full tutorial video, please again, comment you want a tutorial video. I'll walk through setup and everything, but it's really simple. You're going to go to the instructions screen. You're going to set up what's called a Cosmos Predict 1 environment. You've already done that. You're basically skipping some of this, and you're going to go all the way down to this part, and you're just going to install this. You do have to be on a Linux machine for this to work. I think you could get away with this on a WSL2 install, but it could get tricky in the setup. For me, I use in Linux, and I have at least 48 gigabytes of RAM because these are pretty large models. Once you got that installed, I'm going to show you the GUI usage. Now, I didn't actually get the GUI usage to work on my computer. I do need to make some basically hacks to how this all works locally, but it'll show you basically how everything is made. And then I'm going to show you how this is all ran with command prompt, because in the actual usage, I don't think we're going to have people running around taking pictures and manually creating trajectories and creating these cool fly-throughs. I think we're just gonna have automation through command line. But so for this, for the GUI usage, they have these dedicated instructions. Again, I'm not gonna go in depth into it, but basically you create a server on your local machine and then you start that server instance. It's actually super easy to get set up. And if I bring up my terminal, you'll see I have a server window running, and then I also launched the Python code right here, and it'll end up launching a GUI. So here's the interactive GUI, and I'm gonna show you a scene that I first did my first test on. This is called Weatherford Hall at Oregon State. And if I go bring up my source images, it looks like this, which is a great photo. And I basically take where this photo is located and I put it right in here and hit seed, and it turns it into a 3D model, which is incredible. Again, it's using like depth anything or a 3D model. It's using AI to predict the depth. It's not perfect. If we kind of like look down straight on top, things aren't perfect, but it's giving the generation system an idea where things are. One thing I noticed is if I go look at that photo again, they have these trees at the top. Those got caught in the 3D model, and so it doesn't know those little thin trees are there. So again, the AI is not perfect. And then I have this cool like camera. If I move him, you will see here it moves on the left side, and I can start to build a trajectory. So, from here, I can, you can add these keyframes, and I'm never great at this. I think you can do one like this and hit add from cam. And so it'll add it from like my viewpoint. Then I can move over here. I hit add from cam and just move my way along like this. And then you'll be able to replay that. So you can see there's this cool curve. And then if I play that again, hit play, you're going to see that that is the path that I created. And you start to see there's a lot of occlusions, a lot of area around the building it does not know. And so you start to basically build up this interesting 3D scene, and it has some geometry informing it at the bottom here. One thing is going to happen is normally that's all I need to do to generate this file. If I hit generate here and you're running this on a server that has an appropriate hardware, you're going to get a cool result, which I'll show you what my result looked like. But I'm going to hit that button and you'll pretty quickly find that it's going to crash. Okay, so I tried running it and it says I ran out of memory. Of course it crashed. That's just because when you're running it on the server, it doesn't do any task offloading. It just assumes you have like 100 gigabytes of VRAM, which I did not. But I can run this in command line. So what I just showed you, I can easily run in command line. So if I go back here where it says generate 121 frame video from a single image, you're basically going to pass that same thing in, and you're just going to specify where your image is. And if you're smart, you just create a notepad like I always do. You can just start editing these and putting in the right files, and that way you're not working in command prompt. Now, do know if you go to the bottom here, it says GPU memory requirements. You need to add these to the end of this part or this part, so you'll make sure you get a good output. So with that, let's see what the output looked like on my computer. Okay, so here's the output. I did this rising scene. So I didn't know what the sky looked like behind it. And notice it does some weird warping of the trees. That's because it doesn't quite know where those were. And we can look at another one where I move, I think, to the left or right, like so. So we're doing this panning motion. It made up trees that I didn't know were in the background. So it's able then to create these great looking simulations from a single image. So again, I have this cool Weatherford Hall rendering, and it all started out with a single image that looks like this. So if I go back to the project page, you can see you can add all sorts of trajectory types. You can say, I want to move the camera left, right, up, down, zoom in, zoom out, clockwise, counterclockwise. You can even specify how the camera, does it stay centrally located? Does it stay, does it rotate? Or is it a trajectory line? So like, do you want it to pan, or do you want it to truck down the scene, things like that? And then how far you want it to move. So let me give you a good idea of what those each look like. Let's start with the camera movements. I have a good example of that. I'm going to play on my screen the example of each one. So we have left, we have right, we have up, we have down, we have clockwise, we have counterclockwise, we have zoom in, and we have zoom out. Okay, so if I play the down, you'll notice it goes underground, which is not great. As I get further on, we start to see that's not realistic. So car wouldn't go there. So that is one hard downside about using these prompts, and I can't create my own trajectory, is that it doesn't know that the camera can't go underground. If I also bring up the clockwise and counterclockwise ones, let's just pull up clockwise. Again, it goes even more underground, and that's not something that can happen in real life. I also saw that if I'm looking at these, things can get, if I frame it and you get too far off, things can get a little smeary. I want to point out this is all built on Cosmos Predict 1 as the diffusion renderer that predicts what these scenes will look like as you get far away from the camera. Now, Predict 1 is an outdated model already. So when this was built a couple of months ago, maybe 6 months ago, that was what was out. There is Cosmos Predict 2, which will be a subject of a newer video coming up soon, but that is a better version of this. And there's also all sorts of stable diffusion video, renders that you could hook up into the Gen 3C pipeline if you want to use something else. However, the great thing about Cosmos is that it is geometry aware and it is going to give you the best results. So we're looking at here, things are a little smeary. They will get better as the predict models continue to improve. Another thing I want to point out on this left one is that a comment I got on the first video I showed at the start of this is that the Chinese text was not great when it was showing new text. Well, that isn't just for the Chinese languages or non-English languages. As you can see, like the buses only gets a little smeared, and then there's some other places where it's trying to come up with text. It's not trying to come up with exact text. It's just trying to show you that there's a sign marquee there. And to an AI perception model, it's probably not going to read the text anyways. It's just trying to say, that's a sign, that's a building front. I recognize this. There's lettering on those things. And that's what it's trying to do. Maybe not great for Hollywood VFX, things like that, but great for these machine perception models. Going back to this as well, I didn't have different versions of the different camera rotations. If I pull up that first video, you can see I do a curve to one side and then I do a straight pan. And so you can do different movements without panning or curving the camera. That's how that works. But I did do a great test on movement distance. So I'm going to bring up another video that shows you 3 different movement distances, and you can see that. So on this top one, you'll see that the camera moved what was the default 0.3. I don't think that's meters. I'm not exactly sure what that means, but you get a little bit of that parallax movement. It looks really convincing. Notice the lighting on the water. The next one on the bottom left, I doubled that distance. And so you get a little bit more movement. It has to predict more of the scene, but things still look really good. And the last one I did 1.2. So that's what, quadruple the movement of the first video. And it starts to have to predict. So if you look at the far left, you'll notice that building, it doesn't have like archways and windows like you'd expect. This is in Venice, Italy. You would expect that. But it didn't know it's there. So it's just trying to predict there's another building there. And what is impressive is still majority of the scene, it looks coherent, it would work well, and the perception model should understand that this is a waterway with buildings flanking it. So now I want to show you my tests with dynamic videos. So dynamic videos are a lot tougher. I tried this as a sample video. I think this is my most successful one. They don't give you great directions on how to prepare this. So I literally had to build my own SLAM pipeline to make it compatible, which I will eventually share, but I keep improving it. But I want to show you some of the results I got from using that. So if I go to my results folder, this was my first test and it was looking good until it got really far off. And then things started to look like, I don't know, an earthquake. I don't know, something bad was happening in the multiverse. So I thought the problem was the fact that I used Midas, which is like an outdated SLAM single image depth estimation. So I'm going to show you this one. This one I used depth anything version 2, and I think things got worse. It almost like a VCR trying to track the scene. Not great. So I tried one more method. I tried video depth anything, and again, things kind of fell apart. But I thought maybe it's because it was the motion. So I have a couple of these. So this one, I thought I'll try a different movement. This was again Midas. It looks okay. Things kind of go weird with her, like her foot. And so I tightened up that spiral one more time, and I used what I thought was my best SLAM, and I got this one. So this is looking good. Don't look at her leg. But what's interesting is that it actually simulated like light. The trees are a little wavy, like there's some wind, but then again, the ground's a little wavy. So not perfect. And I was not able to get a great video to video generation using this scene. I also did another one with this robot. And again, notice it gets a little smeary. This was a locked off shot in the original one. And then I tried panning and things kind of fell apart. So overall, you can do video input, but I don't know what the bounds are. All the examples on the project page have like small movement and a kind of a locked off video shot. They did provide some examples that worked better. So I don't know if it's because I wasn't wiring up the SLAM correctly or what, but they do have a new code repository called Vipe that just came out that will be compatible once they make some upgrades to Gen 3C, and I will probably do a follow-up video on video to video generation if it turns out looking good. And so with that, I actually wanted to look at a couple other edge cases and show you where it did well before we wrap up this video and kind of give you my general overall thoughts. So the first thing I did was I wanted to see what it looked like when we used a mirror in the scene. Was it getting able to like double up the scene? So with that, I took this hotel room mirror and it does a really good job. But if I pause it at the end, let me go through it one more time. As I pause it then, you'll notice it's missing this side table and the bed itself looks a little stretched out. So let me just go to the end one more time, like so. I'm gonna pause it. That looked pretty good. And at then you can see the bed looks a little stretched out. It's missing that side table with the laptop. But I think this is really convincing. I don't think people would notice that unless they're really looking at it. So A+ on the mirror, that was incredible. The next test was this, where I had light cascading through trees, and I want to see how well that like sun worked at the tree occlusions. And again, it nailed it. This is one of my favorites. It was really good. I thought this looked really fantastic. I was able to kind of simulate that. And as you saw at the start of the video, it did really well with light. That is something as a pattern it does well with. This test was using historical footage. It didn't turn out so well. I noticed as well, it didn't have a good idea of the depth of the scene. And so it's panning kind of to the wrong thing. But I did do the same scene as a zoom out and really try to zoom out far. And it worked really well. Again, we all know this pyramids. This was from like the New York City archives. And it ends up with this cool kind of like parallax looking scene. So it could even work with this old historic footage that was scanned. This is like from a real film camera a long time ago. This is my last test. I really loved this video as well. This was a SpaceX launch. I actually meant to pan the camera the opposite direction to wonder how I do with the lighting of, you know, that rocket. But the test ended up being how well can it come up with clouds and smoke. Remember that this is built on a Cosmos prediction World Foundation model, which does not have everything under the sun in its 10 million hours of training. So I'm like, does it have satellite launches? Does it have smoke and clouds? And it nailed it. This one's just crazy to me. It looks really cool. I wish the rocket was moving up, but I take what I can get. Okay, so now you've seen the data. I thought I'd give you my overall thoughts of how well this worked and where I see this going. So if I start out with the good, again, I pointed out what's amazing is that I can take a single image and then create a dynamic scene out of it. And if I want to, you know, give 100, a million different viewpoints to a robot to train on from a single image, this is going to give me the ability to do that. It's also great that I can just run it from command line. I don't have to be physically building these trajectories, things like that. With Gaussian splatting, which is really cool, you end up doing a lot of manual work. And if you need to do this at scale, you need to do it fast, you need to do it automated. And that's where this kind of comes in, where I can just batch a bunch of images, a bunch of trajectories and different parameters, and just create those video snippets in the end. They're really good. But there is some limitations, as we saw. The output video is not super high resolution. It comes out as a, I think 1280 by 720. For machine perception, that's great. You want to use this for, I don't know, VFX production, something like that. You're going to need a higher quality output. And that could be a mix of the limitations of Cosmos today, but also is also a limitation to my hardware. I'm running this locally. If I want to do this at 4K, I'm going to be pushing it to a much bigger server. Also, we saw there's some work to be done on video to video. That could be my end. That could be this. But what I think they created here is a great foundation for taking imagery and basing it in a real 3D world and doing diffusion on that and making sure that the scene still makes sense as you look at it from different viewpoints. You want to make sure things aren't wildly moving out of the way. That cool parallax one I did of the pyramid and of the Sphinx, that one was really cool because you had this kind of realistic depth of field going on right there. And I feel like with the improvements that we're going to see in the World Foundation model from Cosmos, this is only going to get better, because the Gen 3C part is how they basically pipeline in that diffusion rendering and the 3D model and the depths and fuse those together and fuse those together to get you this really realistic scene. I think that's just going to get better and better and better. As we saw even in nerfs and 3D Gaussian splatting and video diffusion, things are just moving at a lightning pace. So if we revisit this in a year, I wouldn't be surprised if this looks 10, 100 times better. So again, if you want to try this out yourself, again, I will link the repository in this video, and comment if you have questions. The people who built it are really responsive as well on GitHub, and I would love to see what you produce. And if you like this sort of content, I have now 15,000 subscribers. I don't know where y'all came from, but I feel like that we're at the precipice of this 3D reconstruction and generative AI for industry, and I want to make sure this content gets out to everyone who finds it useful. So if you did find this useful, please subscribe to my channel so you can get more videos as I produce them and give you a little bit more hands-on look to how all this code works. And with that, I'll see you guys in the next video.